Hello, everyone. I'll introduce myself. I'm B.J. Hargrave. I work for IBM. Some of you may have seen me at past ClipCons, but I've been working with OSGI for almost forever, basically since 1999. I was there when we did the first release, and in fact, the log service was one of the first 4 specifications that came out in Release 1, so it's pretty old. It's been around a long time. And so I still work on OSGI today. I represent IBM there technically. I'm also sit in the role of the CTO of the OSGI Alliance. So I'm the chief technical guy there. So know lots of things about OSGI. Been working with Java for a long time too. And so today we're going to talk a bit about the new logging service. So a couple of questions first. How many people here have ever written a log message? Okay, good. So you know what logging is. I don't have to explain what logging is. Second question: Who was anyone here at the BOF last night? Right. So anyone here at the BOF last year? If you were here last year and you went to the BOF, you saw Ray in the back who was super excited about the new log service. And so now I'm going to spend some time telling you why Ray was so excited about the new log service in OSGI. So, as I mentioned, logging, right? We have a log service in the OSGI spec. Everyone logs. It's so common, it's almost an afterthought to log these days. But of course, back in the day, back in 2000 when we released Release 1, logging was still sort of in its infancy, right? The original log service that we introduced was pre all sorts of ideas. We defined that service before we had even invented the whiteboard pattern for OSGI. It existed before log4j, before SLF4j. Logging wasn't what we know it is today. And so at the time we created the log service, it was fairly simplistic. It wasn't very powerful. It wasn't very thrifty. And so it sort of was very awkward for people to use in a modern sense, as we know today with logging. And so we actually had several updates to it, 1.1, 1.2, 1.3, as we went through a few of the OSGI spec releases, but basically those are almost not micro updates. They're very, very minor, adding a few text strings to support some new events that the framework was publishing, but we really didn't change the API that you, as a bundle programmer, would use to do your logging. And so this time, for R7, version 1.4 is a big update, huge. In some ways, we basically threw away the old log service and we're giving you a brand new log service. But it's still backwards compatible, so all the bundles that exist that might write to the old log service, those things are going to keep working. So we're very careful at OSGI not to break the past as we move into the future. But the key thing, right, is you're going to put out a new logging API today, you have to look at the universe of logging APIs that are out there and make sure that you're on par. Right, so what we did with the version 1.4 is we took inspiration from SLF4j, which is probably, I would say, the most popular logging API today out there. And we took those things and expanded on them and adapted them and made them fit into the OSGI world. And in fact, this change enabled some very interesting ways to use logging, integrating with other code that just uses SLF4j or other loggers. And I'll talk a bit about that later in the presentation. So from the spec, we got a bunch of new types that exist, right? So in the past, we had the log service, which is what everyone needed. You'd have to go to the service registry, get one of those, and call log as you need to log things. So we've changed the API a bit by adding some types you might recognize if you're an SLF4j user. We have a logger factory, and we have loggers. And of course log levels. So we've modernized the API, and in some ways it looks very much like what you might see in SLF4j. So the key thing, like in SLF4j, is the logger type. This is the one that you will interact with the most as a developer, right? So the key thing is you want to get a logger object, and then once you have that, you have the message on it that you can use to do this kind of logging you're used to doing. We have methods that are log level specific, right? So instead of having to pass the level in as an API, as a parameter to the log API, there's a method, log debug, log info, very familiar if you're used to SLF4j. Loggers have names on them now too, right? So instead of just one big flat space of logging that existed in the old log service, each logger now has a name. And because loggers have names, you can configure those loggers. How detailed do you want the log information from this named logger or this group of named loggers? We also support message placeholders, right? As part of thriftiness in logging, you don't always want to do work if the log level isn't enabled. In the old log service, you could basically log a string message. And so if you wanted to do debug logging, you had to build the entire string out of all the parameters. But if it wasn't debug logging, of course, you just wasted a lot of effort for no purpose. So like SLF4J, we basically can defer all of that string construction by letting you pass arguments that we only construct into the message if the log level is in effect. The one sort of extra feature we have in the OSGI log service is we support a variant of logger called a formatter logger. So instead of using the sort of simple curly brace message placeholders you're familiar with in SLF4J, you can actually use the formatter style placeholders you used to with printf, %s, %d, and you can have a much richer formatting style to format your log messages. And so this is a choice you can make when you ask for the logger, whether you want, which kind of placeholders you want to use in your logger. The other thing that we did, much like SLF4J, is in addition, when you pass your arguments into your log method, you do log debug or log error, sometimes, certainly if you have an error, there's an exception involved with it. And so we actually have a special support in the logger so that if the it looks at the last parameters that you pass to the message, and if one of them is an exception or one of them is a service reference, we specially capture that out of the arguments and place it in the log entry in the appropriate field so that you actually can have the real information there as opposed to just formatted information in the string. And so if you look at these types in Eclipse, right, you'll see they look almost the same. On the left is the SLF4J logger, on the right is the OSGI logger. Right, and so the methods are very similar. There's a bunch of debug messages and info messages and warn messages. You can interrogate whether the level is enabled if you're trying to decide whether to do some work before you log. We even have a special variant of the messages that take a lambda. So you can use a logger consumer. And the interesting thing here is that you don't have to do the simple constructs where you do is, log level enabled, curly brace, do expensive work called log method. Now you can actually just pass in a lambda, and we only evaluate the lambda if the log level is enabled. So it's a bit more modern, sort of Java 80 style of doing logging, that you want to do conditional work only if the log level is enabled. So that's pretty cool too. Much like SLF4J, we have a variety of log levels. Most of these are probably familiar from the old log service. I think we added trace at the bottom, so that's a sort of very chatty, super chatty log level. And the other thing we added at the top is an audit log level. So this is something you can't turn off, right? So if there's certain things you must always get into your log, you can use the audit log level. And there's no way to disable that through configuration of logging levels to shut it down. So that just gives you an always logged level. So then the question comes, how do I get a logger, right? So in the SLF4J world and most of the other loggers is some sort of static factory method you call to get your logger. Logger factory, get logger, name. And so that's okay, but it's not very OSGI, right? Because OSGI is all about services and dynamics and all the other good stuff. And so, of course, in OSGI, we have a service to get a logger. And so what we did was we took the existing log service, and we refactored it so it now extends the logger factory. So we basically dropped an interface in the type hierarchy below log service. And so when the implementation of this spec registers a service, it registers it under both names, log service for the legacy users, so they still can get the log service, and it's also registered under the logger factory name. So the newer guys can ask for it under the new name. It's the same exact object, but you have two views on it, the old log service view and the new logger factory view. And in fact, if you have code that you compile that use the old log APIs, if you compile it against the new log service, you'll get some nice deprecation warnings from the old log methods, telling you to update your code to use the new logger stuff. Logger names, like in SLF4J, form a hierarchy. Typically what you use for your logger name is your class name, right? So you get the nice reverse domain naming, com.foo.bar.class. And so this gives you a nice hierarchy over which to organize and manage the chattiness of the logging from that thing. So you can set the log level for one at a different level than another. And we also have a special logger named the root, which is the ancestor of all loggers. So again, this is very much like SLF4J. And so the key thing with the name hierarchy, of course, is this is how you manage your log configuration, what gets into your log, who gets to send debug messages, who doesn't. So in the OSGI way of having services to do things, we have a new service called the logger admin. And so this is how one configures logging. And so basically the logger admin gives you, as a service, gives you access to logger contexts. So each bundle in the system can have its own logger context. So let's let you configure logging for a specific bundle. We also have what's called the root logger, which is a sort of the system-wide logging context, and that lets you control the logging across the whole system. And so using sort of the data that lives in a logger context as a map. So you have a map of logger names onto logger levels. And so in the example here, the logger name comfoo.bar is logging at the info level, but people at comfoo are at the debug level, so any comfoo.baz would be logging at the debug level. So this gives you sort of very fine control over what's going on. And we also have this hooked up to our friend configuration admin. So basically what you can do is you can either directly talk to the logger admin API to manipulate how you've configured the log levels, but typically what you'll do is you'll use config admin, right? So we have a special PID space that starts with org OSGI service log admin, and using PIDs that start with that prefix, you can set configurations in configuration admin to control the logging for a system as a whole. So this is sort of very powerful because it lets, say, an operator send updated logger configuration through config admin to see what's going on. If there's some problem, you can push down a new config admin config, and that causes more or less logging information to come from one bundle or another bundle, depending upon the bundles that you're configuring for and the log names that you've set the levels for. So it gives you a lot of flexibility and a lot of power in how you can control logging, right? Now, typically, most people are probably going to just program the root logger context, right? So this is the bottom of the logging configuration, right? So the default will be, you know, error for the root logger and the root logger context, and only errors will be logged. But sometimes you want to have debugging, so you might turn debugging on for the whole system through that, or you might turn it on just for a certain sort of name hierarchy in the loggers. But if you want, you can even turn it on just for a specific bundle. Say, if this bundle logs, he should have debugging, everybody else is on error. So you really have a lot of control over how you adjust the flow, the types of logging that comes out, whether you're trying to really look at a certain bundle and see what's going on in it, or whether you want to look at the whole system, or whether you want to look at a class or a type hierarchy in the loggers. There's a lot of power in the system and how to configure it. So we got this new fancy logging API. And so the question is, well, where does all this stuff go? I've logged and logged and logged, but where does all of that stuff end up, right? So typically, you know, in a sort of SLF4J kind of world, you have some sort of back end you configure for the API, right? Maybe it's logback, maybe it's just simple, or maybe it's NOP because you don't really care about it, but you have to provide some implementation. In the OSGI world, logging basically doesn't go anywhere unless you have somebody consuming it, right? So basically, in OSGI log service spec, the logger service implementation is really a broker. He is a broker between the people that are logging, pushing information out, and anybody who might care about that, right? So basically, if you want to do something with the log, you need to consume the information coming out of the log, coming from the log service, right? So in an SLF4J world, you might say, well, I need to set up an appender who is the receiver of what is logged through SLF4J. So in OSGI parlance, this would be writing a bundle that actually consumes the log information, that listens to the log stuff, right? So you can either use the log reader service, which is from the original spec, right? And you can add a listener on that, and he'll get called every time a new log event is logged. But in taking advantage of some of the new features, we also have a new log stream provider service that's been added. So the log stream provider is basically, if you think about a log, right? A log is really just an asynchronous stream of events. Things come in at some unknown rate as bundles decide to log, right? And so as the receiver of the log information, it comes to you as a stream, asynchronous log, series of events. So this is a perfect opportunity to use a push stream, right? A push stream is a new spec that came out in R7. And it's basically like streams in Java 8, if you're familiar with streams. Streams are a pull technology, right? You configure a stream, you put some maps and filters, and at the very end you go collect or for each. And at the end of that stream, that terminal operation is a pull. It starts pulling things out of the stream. But whereas a push stream is the other way around, is it's the provider who pushes things into the stream, much like logging is, right? The loggers, the guys doing the logging, are pushing things in. And so you can use a push stream to consume the things that come out of the log, right? So this is a more modern style of consuming the log, but we actually still left the old log stream reader in there. And part of that was just to make life a little easier for some implementations. So the old log reader is still there, and in fact, if you look at how Equinox as a framework implements it, they actually put the log service implementation of this new spec right into the framework. It's baked in. And of course, Equinox has other constraints. You know, they have a lot of downstream customers that aren't necessarily interested in all stepping up to Java 8. So Equinox, at this point in time, is still compiling to the Java 7 language level. And of course, push streams uses streaming and lambdas and other things, which is all Java 8 technology. So we actually kept the log reader part of the spec intact so that Equinox could implement the main logic of the log service implementation in the core framework, but could implement the log stream provider part as a separate add-on bundle. And that bundle, of course, then would depend on Java 8. So as a consumer of log stuff, right, you can choose either way to get the log information, either sort of from the old logs reader service or from the new push stream-based log stream provider. So, but the key thing there, again, like the original log service, is all the old code still works. So if you got code and you're happy with it, you don't need to change it, but there's new stuff you can take advantage of. Right, so as part of the new logging stuff, right, there's new things you can log, right? And much like the information one can get from an SLF or JLog, we wanted to expand the set of data that was available in a log entry in OSGI as well. So we have a type called the log entry, which is basically the event that is created as a result of logging and that is then pushed through to the log reader service or the log push stream. And so we extended the log entry to add new data that's collected at the time of logging. So in addition to sort of like the message string and the bundle who did the logging, we also add some other stuff, right? Obviously now we've got the name of the logger because loggers have names. So we collect that. We also put a sequence entry, right? Because sometimes you might see some log data out of order, but by putting sequence numbers on them, you can reorder them or validate that they come in some sort of arrival order at the log service. And we also collect some thread and stack trace information from the call site. So when a log entry is made, we collect a stack trace element of who the caller was as well as what thread that the caller called on. Because sometimes this information is very useful in sort of trying to understand what happened in a system, who did this log, what thread did it, you know, that sort of thing. Those can be quite useful for developers in trying to decode why stuff isn't doing what you thought it was going to be doing. So, and the other sort of really cool thing, I think, is the integration with declarative services. So how many people here use declarative services? How many people here have used the log service with declarative services? Yeah, less. Say, you know, it was kind of awkward before because you had to have a log service injected and then you had to, yeah. So the neat thing we did with DS in 1.7 is we decided to take this new support we have for logging and integrate it really well for the developer experience in using declarative services. So now if you need a logger, right, so here's my bundle, my component, example impl. So I need a logger, and I want my logger named for my type, which is sort of the convention. You name your loggers after the class that's doing the logging. All I need to do here is put an @ reference on a field, for example, or you could use constructor injection if you're into that sort of thing. You put an @ reference on, and the key difference here is that you have to say that the service you're asking for is the logger factory. And then declarative services at runtime, the SCR, will actually look at the target of the injection site, and he'll look at the type of that injection. So he says, oh, the type isn't logger factory, it's actually logger. And so under the covers, on your behalf, SCR will call the logger factory and get a logger named after the implementation class of your component. So he'll handle that for you. So all you get is you know that when your component is activated, there is a logger there. That logger is named for your component, and you're ready to log. So off you go to the races. So it's very sort of super convenient for declarative services programming now. You don't have to do much at all. You don't have to write any complicated calls to get loggers. You just have to say, inject a logger right here, and you get what you expect. So that's I think a very neat sort of synergy between declarative services and the logging stuff that makes it ridiculously easy to log now in a declarative services component. But then you say, hey, I'm writing my OSGI bundle, and I'm good with this new log service and these loggers, but I use lots of open source projects. And all of those projects, they're not so keen on necessarily on OSGI. They don't hate it, but they're not going to tie themselves to it, right? They have other customers that don't use OSGI, so they're not going to use the OSGI logging service. They're going to use SLF4J probably, right? That's probably what most of them do. And so what the hell do I do now? Right, so basically we have, when you're building a real system, right, you have many different parties involved, open source projects, third-party code that aren't all using, the logging stuff. So you have many different APIs that people are logging to. And really what you want as a whole system is you want all those logs together, right? You want the final result to all be sort of nicely interleaved in time so that when you see the collective log, right, it's from no matter what API someone used, you see the complete and the whole log in order so that you can sort of look and analyze and see what's going on. Why is this problem happening? Because I call this guy who called that guy who'll call this other guy, and they're all using two or three different logging APIs. How do I handle that? So the key thing is what's the way to deal with that? So there are a couple of I think two basic strategies that we can look at for handling this, right? So one is basically what is the back end you want to collect this information? Right, so one thing is basically send it all to a back end like Logback, right? So we want to configure our system so no matter what logging API you use, all of the information ends up in Logback. Or another strategy is if you're really into OSGI and you're mostly all OSGI logging, but you got a couple of oddballs that are using SLF4J, you might say, well, my preferred strategy would get all that SLF4J stuff into the OSGI log service, right? But the basic goal here is at the end, you end up with all your logs in one place as opposed to in 2 or 3 different places, and you have to somehow rationalize them as you're trying to figure out what's going on in your system. So I got a couple little projects I worked on to sort of demonstrate these, and we'll go to Eclipse and take a peek at it. So this first one I call SLF4J over OSGI. And so this is a case where we want to take bundles that are using the SLF4J API, and we want to collect their output and stick it in the OSGI log service. So basically all of the information ends up in the OSGI log. So let's see if we can get this to work. And we go to Eclipse. Right, so I wrote this it's a sort of complicated piece of code here. So basically, I had to write, I don't know how to make this much bigger, but I had to write an SLF4J implementation class, right? And so this has the usual suspect of I have to write a static logging binder. You see that? And so this is basically pretty much boilerplate SLF4J stuff, right? So if you want to write your own implementation of SLF4J, you have to implement a few classes. One of them has a fixed name called static logger binder, and you write some code, and you have to implement this method, and then you end up, doing something like writing your own class that returns a logger. And then of course, the real problem we have here, as you can see, there's lots of stuff in there, is that we basically are trying to take a static API, which is the SLF4J API, and we're trying to layer it over a dynamic system, the OSGI log service. So we have to do lots of games and things to play with it, right? So we've got to have, we have to track in this code the logger tracker because it might come after people have started logging already to the static API. And we've got to have maps so we have to create a mapping from SLF4J logger objects onto OSGI logger objects so we can pass it through. So this code basically handles all of that magic through a lot of unfun things. But at the end of the day, right, we end up with a layer that layers SLF4J log calls into the OSGI log service. And so we have a little. This is all done, of course, with nroute. So I used nroute to build this project. So it's all based upon our new nroute archetypes. And I have a fine little debug run here. So I can run this code. And you can see when it comes up that there's just a few little something wrote to system error. But there's not a lot of data here. Because all of the logging that came out of Jetty and all these other bundles that were wrote to the SLF4J API, they all got collected up in the log service. So if I go log debug and ask GoGo to dump the log for me, I can see there is all of the logging that was all SLF4J APIs that all got collected into the OSGI log service. So this is one strategy that you can take for how to handle logging in that world, right? It depends on where you want your stuff ended up, right? But this is an example of how you can collect SLF4J static logging API logs and push it all into the OSGI log service, along with other things that are in the log service, right? So this is the complete interleaved SLF4J logging and OSGI logging, all in time, in order, in the OSGI log service. So that's one way to do it. And if we go back, the other thing we can do is take the other strategy. And that says, I want to put all of my logs in logback, right? So SLF4J is configured to go to logback. I want to configure the OSGI log service to go to logback too. So this is a little easier right now because we're layering a dynamic API onto a static backend. So that's much less cumbersome to accomplish, right? And so I wrote a simple little example here that does it in basically one class plus an event class. So basically I wrote a logback component, right? So this guy's just a log listener. I'm just going to register him with the OSGI log reader service. You can see I made him a component here in DS, and when he gets called his activate method, I collect some data from last time to sequence things, and then I just add myself as a log listener to the log reader. And so then when I get called at log entry, I basically just get the SLF4J information, and I push my log event that I create into the logback. So this is the same sort of idea, except now we end up with everything dumped into the logback guy. So if we run him, we'll see this time, of course, logback wrote to the console because it's configured, it's the default console appender. But you can see in here that there are, right, these are OSGI log services, right? This is the framework pushing an event to the log service, but it ends up in logback's back end. So this is another strategy you can use depending on what makes sense for your application. But the key thing here is you end up with everything all in one place, regardless of whether people are using the OSGI log service API or SLF4J, for example. And of course, what I did is just a simple example, right? I hacked that together in an hour or something. There's actually a really cool project that Ray did at Apache Felix called Apache Felix Logback, and that took what I did and turned it up to 11. Basically, he's got it very nicely set up so that all of the logback configuration is, for log levels and all that sort of stuff. He mirrors it into the logger admin service in OSGI so that you can configure OSGI log levels through your logback configuration, which is pretty cool. So I would certainly recommend checking out the Apache Felix Logback project on that. So a couple of notes on the demo I did. Basically, I used the Equinox framework, which, of course, has a built-in log service implementation, right? So in order to make this sort of work, because my bundle got started after the framework got started, and I didn't want to impose any ordering between my bundle and other bundles, I configured the log service to have a history, right? So I made the log service implementation buffer up log events so that when my little bundles got started, I could go read that history out and then process it. And I also had to configure, for the purposes of demonstrating that I actually got some log entries. So I turned on logging to debug, so we had lots of things to look at, and it makes my demo look nicer. So that is logging. Any questions?
We have time for a couple of questions.
Yeah, go ahead. It's always collected as part of the log entry, right? So when you log, you don't have to do it, but when there's a entry that's created out of your request, and in there we capture the message, what bundle logged, did he pass a service reference, did he pass an exception, who called us, what time did he call us, what sequence number is it, right? So we collect up, all right, a set of information, and so part of that is the name of the thread that called us, as well as a stack trace element, so we can say this is the code that called us. I don't think so. I mean, it's also done by SLF4J and Logback too, so it's quite common. It's not something unique to what we're doing in OSGI. Again, we were inspired by SLF4J. And of course, it's only captured if the log level is in effect, right? So if you don't have debug turned on, then all those log debug messages just do nothing. They quickly. Yeah, I don't think the code creates an exception and then gets the stack trace and then walks through it. There's some other API you can call to get that, I think. Yeah. Well, I mean, that's one of the reasons I think that Equinox bakes the log service into the framework, right? Because they're guaranteed it's there, and it's there early. So that was an implementation choice they made in Equinox. Now, specifically, the framework actually never logs. The framework, from a spec point of view, doesn't require the log service. The framework publishes events. So if there's something bad happens, the framework publishes a framework error event. Now, typically, what happens is that, as the spec requires, the log service implementations must subscribe to those events and themselves convert them to log entries. So obviously there is a window if you have log service implemented as a separate bundle that bad things can happen, framework events get published, but no one's there to hear them, and then by the time the log service implementation comes up, he missed them. Which is, I think, one of the reasons, of course, that Equinox chose to implement the log service right in the framework so he can make sure that he gets the log service up ASAP. Well, in that example, yeah. I mean, if you want to make it optional, then of course you could put a different cardinality on it, all right. And then of course, but then you'd have to protect all your references to it, right? So you couldn't just go logger.debug. You'd have to say if logger not null, logger debug, or put it in an optional, right? In fact, that's one of the things people suggested for the next release of DS is that we support injecting into optionals. Right, so then if you have an optional cardinality, then you can just easily write safe code around that optional since it might not be there. I think one more or over?
One more quick one.
Okay, quickie. Right, the sequence number basically just is a time of arrival or time of call, right? So they're just ordered for that purpose, right? One of the reasons the sequence are helpful if you have multiple different log, there are things, if you wanted to try and combine two different logging events, you could sort of use them to order. Yeah, there's nothing in there for that at this time. I mean, that's an interesting question. I know, like, for example, MicroProfile has some sort of logging support to follow microservices from, microservice to microservice. So that might be one way to sort of look at solving that problem. All right. Thank you, everyone.